Hello everyone, this is Rujul Rohit Rajarapullu from C1 Division ENTC department. Today I am going to explain the RSA algorithm, which stands for Reverse Stream and Edelman. It is one of the most important cryptographic algorithm used in network security for secure communication over the internet. Mm. So our next slide is of the introduction. The RA in which the RSA is a public key cryptographic algorithm developed in 1977. It is uses the two keys, a public key for encryption and private key for decryption. Its security is based on the difficulty of the factoring the large primary numbers. So our next slide is need for RSA. Why we need the public key? In symmetric encryption, both the sender and receiver uses the same key, which creates a problem of secure key sharing. The RSA solves this problem by using the two different keys, making the communication more secure. So this is why the public key has been used. So our next slide is working principle of RSA. In which the RSA works in three steps: the key generation, encryption, and decryption. The sender encrypts the message using a public key, and receiver decrypts it using a private key, ensures a secure communication. Here are the images in which we can see the process and the principle of the RSA algorithm. Mm, mm. So the next slide is RSA algorithm steps of key generation. In key generation, we first select the two large prime numbers and calculate the product. Then we compute a public key and private key using the mathematical formulas. The public key is shared while the private key is kept secret. Here is a diagram in which the secret key has been is been shown how it is been used. Hmm. The next slide is for the encryption process. During the encryption, the sender converts the message into the ciphertext using the public key. A mathematical formula is applied so that the original message becomes unreadable to anyone except the intended receiver. So here is the block diagram and the theory given in which we can see the formula and the process and how the encryption method has been performed. Hmm. So the next slide is of the decryption. Here the diagram has been given in which the process has been shown where the how the message has been decrypted. Now in decryption, the receiver uses the private key to convert the ciphertext back into the original message. Since only the receiver has the private key, the data remains secure. Mm. So our next slide is the example. Now, for understanding, we can take the small numbers to perform the RSA calculation. After the encryption and decryption, we get the original message back, which shows how the algorithm works. In the real application, much large numbers are being used. Here, the example has been given in which the encryption has been done using the plain text, and the process has been shown as process has been shown in which the plain text has been converted into ciphertext, and the another example is been shown where the decryption has been done, where ciphertext has been converted into the plain text. So our next slide is the application of the RSA. The RSA is widely used in the secure website, digital signature, and email encryption. Whenever we see the HTTPS in a browser, the RSA plays an important role in securing the communication. Mm. So then our next slide shows the advantages of the RSA. The RSA provides the strong security and removes the need for sharing a secret key. It also supports the authentication, and it is widely trusted and is used in the many real world applications. So there are also some limitation in the RSA. So the limitation of the RSA is that it is slower compared to the symmetric encryption and requires the larger key size. It is not efficient for encrypting the larger amount of data and needs the proper implementation to remain secure. Hmm. So with that, I would like to conclude this slide in which the conclusion I want to say that in RSA is a powerful and widely used cryptographic algorithm that ensures a secure communication despite some limitation. It remains a fundamental part of the modern network security system. Thank you. Thank you so much for watching.